Hi everyone, today we're going to talk about dividing complex numbers. So in our last video we went through adding, subtracting, and multiplying. Today we're going to talk about dividing. A little bit different than the other operations. The key thing here is to make sure that you get rid of I in the denominator. Okay, you cannot have I in the denominator, and so that is our whole goal, is to get rid of it. We've got two different types of division problems. The first one is when you have just a single term in your denominator. So let's say you have something like this. Okay, you only have one term in the denominator. Here's the one thing you have to remember, and I pointed this out in the last video as well. I squared is equal to -1, and this is something that you're going to use a lot, so you have to make sure that you know that. And because of that fact, that allows us to get rid of I in our denominator. What you want to do when you have a single term in your denominator is multiply the top and the bottom by that single term. Whatever you do to the denominator, you have to do to the top to keep your expression to have the same value. So I'm going to multiply the top and the bottom by 2i. Now I could just multiply the top and the bottom by I, but I like to do it this way because I think it's actually easier if you do it this way. Okay, so now when you multiply two fractions together, you're going to multiply your numerators together and you're going to multiply your denominators together. So when I multiply my numerators, I'm multiplying a monomial, which is this 2i, by this binomial, so I just have to distribute. 2i times 4 is 8i. 2i times I is 2i squared. That's important. Okay, in the denominator you're just multiplying these together and you end up with 4i squared. Remember this really important fact. I squared is equal to -1. And so now I can go through and replace I squared with -1. I have 8i plus 2 times -1 over 4 times -1. That leaves me with 8i minus 2 over -4. Okay, so that would be dividing. Now notice I no longer have an I in my denominator. Now what you should always do is put that in simplest terms. And this usually causes a little bit of trouble for people. So what I tell everybody is to break this up. To put it in simplest a plus bi form means you break it up. And I call this kind of some people call it the butterfly, some people call it the crisscross. I'm not sure. There's lots of different names for it. But you're going to break it out into two fractions. 8i over -4 and then -2 over -4. And then simplify each of those fractions. 8 divided by -4 is -2. So you have -2i, and then a negative divided by a negative is positive. Reduce that, plus 1/2. Okay? If you want to write that in a plus bi form, okay, you put your number that doesn't have the I first. So I have 1/2 minus 2i, and that would be in simplest form. So there are a few steps there, but the big thing here is to remember to multiply the top and the bottom by that bottom expression, which is just 2i. Okay, let's talk about one that's a little bit more complex when you have a binomial in the numerator and in the denominator. Before I do that though, I want to talk about conjugates. Okay, and conjugates are so unbelievably useful when you're doing this type of stuff. A conjugate is simply this, and we talked about this briefly before. If you have a binomial, say for example you have 1 plus 2i, okay? The conjugate of that is just this, 1 minus 2i. Notice the only thing that changed is the sign that's between the two terms. Not the sign in front, but the sign that's between them. I went from a positive to a negative. And the reason that is extremely useful is because of this. If I were to multiply any complex number by its conjugate, I am actually going to get rid of the I in the expression. Watch what happens. If you use FOIL, okay, if you use FOIL, that means you multiply your first two terms together. So 1 times 1 gives me 1. Multiply your outside terms or your outer terms. 1 times negative 2i is negative 2i. Multiply your inside terms. 2i times 1 is positive 2i. Multiply your last two terms. Positive 2i times negative 2i would be negative 4i squared. Okay? These middle terms are going to cancel each other out. They're going to add to 0. I now have 1 minus 4i squared. But remember, I squared is negative 1. That is so unbelievably helpful because now I can replace the I squared with negative 1. Negative times a negative is a positive. I end up with 1 plus 4, or I end up with 5. Okay, so conjugates are super, super helpful because they're going to help us to get rid of that I that's in the denominator. Let me show you how we're going to do that. If, for example, I have 5 plus I, actually let's do this, 2 minus 3i over 5 plus I. I am automatically, as soon as I see that binomial in the denominator, the first thing I'm going to do is multiply the top and the bottom by the conjugate of the bottom. Because whatever I do to the denominator, I have to also do to the numerator. So notice, I don't care what's in the numerator. It doesn't matter. It could just be 7. It could be 1,000,000. It could be 2 billion minus 4i. It doesn't matter what's in the numerator. I'm only concerned with the denominator. And I'm going to multiply the top and the bottom by the conjugate of the bottom, okay, of that denominator. So here we go. If we multiply the numerators together, I have to FOIL. This is something that you've done already. I'll do it down here. 2 times 5 is 10. 2 times negative I is a negative 2i. Negative 3i times 5 is negative 15i. Negative 3i times a negative I is positive 3i squared. Okay? I squared is going to be your friend when you're doing any of these types of problems. Now let's go to the bottom. We're multiplying conjugates together. 5 times 5 gives me 25. Multiply your outer terms, you get negative 5i. Multiply your inner terms, you get positive 5i. Multiply your last two terms, you get negative I squared. The beauty of conjugates is that these middle terms are always going to cancel each other out. That's why you use conjugates, because you're trying to get rid of the I. That is always going to be the case when you're multiplying conjugates together. Let's go ahead and simplify our numerator. We can combine our like terms. We have 10 minus 17i plus 3i squared. Remember, I squared is negative 1, so I'm going to substitute that in. In the denominator, I have 25 minus I squared. I squared is negative 1, so I'm going to substitute that in. In the numerator, then, I have 10 and negative 3 gives me negative 7 minus 17i, and this negative times, or minus negative 1 becomes positive, so I end up with 26 in my denominator. I can't simplify that anymore, because there's no common terms between 7 and 17. I don't have any GCF. There's nothing for me to factor out and reduce. So that's my final answer. I will write it as 2 fractions because that is simplest a plus bi form. You'll see that expression a lot. And there is your answer. If you leave it like this, that's fine, unless they tell you to put it in a plus bi form. That means writing it as 2 separate numbers. Okay? So that's just a little practice in dividing complex numbers. Watch it through again, work through the problem again, and make sure you understand how to go about doing that. Okay, the next thing we're going to talk about is powers of I. This comes in really handy when you're going through simplifying something with different powers of I. The great thing about I is that it goes in cycles of 4. Okay, so think about this: I to the 0 power is just like anything else to the 0 power. It's just going to equal 1. Anything to the first power is just that thing. We already know what I squared is. We know that I squared is -1. I to the third would be -I because it's the same as I squared times I. It would be -1 times I would be -I. I to the fourth would be I squared times I squared, which would be -1 times -1, which would be +1. Okay, I to the fifth then would be I to the fourth times I, which is the same as 1 times I, which is I. And if you notice now, we start going through the same cycle again. So whenever you have a power of I, there's only 4 different ways it can reduce. It can either become 1, it can become I, it can become -1, or it can become -I. Those are the only 4 choices. That's it. So let's say, for example, I asked you to find what is I to the 16th power. Well, I don't want to sit here and do this all the way up through 16. What I am going to do is I am going to take that exponent and divide it by 4 because I'm going in cycles of 4. Okay? If that's evenly divisible, which it is, and I don't have any decimal here, then I know my answer is going to be 1. When I have different decimals here, that tells us what our I value is going to be. So let's say, for example, I did I to the 17th. So I did 17 divided by 4. That would give me 4.25. Because I have that 0.25, then my answer here would then be I. Okay, the next one, let's try I to the 18th. Well, if I did 18 divided by 4, that would be 4.5. That would give me I squared, or -1. And then I to the 19th would be 19 divided by 4, which would be 4.75. And that would give me -I as an answer. Okay, so this first one would be 1, this would be I, this would be -1, and this would be -I. And it's all based on that decimal that you get. We'll review that a lot more in class tomorrow. I just wanted to give you an idea of what's coming up. There is a question on your assignment tonight. It's problem 17. Give it a shot, see how you do. We'll talk about it more tomorrow. I'll see you guys in class tomorrow. Take care, everybody. Bye-bye.